Alright, we're ready to get started on our building a server out of real hardware video. I decided to do a video. I figured that was the best way to go in this case. I seem to be doing more and more of these. I'm not sure if I want to put a stop to this or not. Anyway, we got to get our case, motherboard, and all that other stuff. So I've been told up at the top of the staircase behind me and in a closet up there, there's a computer that I can use. So I'm going to go up there and see if I can find it. All right, heading up the staircase now. Up we go. Well, that must be the closet there. Hmm. There we are, way in the back there. Gonna have to go dig it out. Okay, that was a bit of work getting it out of the closet, but there it is. I was a little nervous considering how far back it was in the closet. I need to get a workspace where I can work on this thing. So that's the next step, is to get it opened up, look inside, and see what we've got to work with here. I got a few other parts I scrounged from various sources, and we'll see how it all goes together. Yeah. Oh, it's got a DVD player on it. Case looks pretty decent actually, but we'll see what's inside of it. I can see there's some dust in the front there. But yeah, once we get it taken apart, we'll have a better idea what we're working with. Okay, remember I said I had some parts I've dug up? Well, let's take a look at what we got here. This is an SSD. It's a little dusty. It's 120 gigabyte SanDisk. I'll have to look up the specs on this one. Have found another SanDisk. This one's an Ultra Plus. The other one was an SSD Plus. And this one's a 256 gigabyte capacity. So again, have to do some research on this. Also found this one. This is a 512 gigabyte. I don't really know this company. Again, I have to do some research on it. I don't think I'll be needing this. Anyway, moving on. Then we got these two are similar 1 terabyte hard disks. They're all Western Digital Blue. They're older. They're not brand new. Older drives. This is also a Western Digital Blue drive, but it's a slightly different manufacturer, model number. It's somewhat different than the other two. But it's also 1 terabyte. So I've got 3 1 terabyte drives, and I've got the 3 solid state drives, which should be plenty for making a server. I did notice there seemed to be another hard drive in the server. I'll have to take a look at that when I get the chance to open it up, and I'm guessing there's probably a boot drive in there, maybe another solid state drive. We'll see what's there. But yeah, these are the parts I found to use with this. Working outside because I don't have a lot of room inside, so got these handheld screws. I also need to locate my toolbox, but I want to get this thing taken apart and take a look at what's inside. I can sort of see there's something over here. All right. Yep, filter on the top. Yeah, there's some dust. You have to clean these out. Yeah, there's the hard drive inside. That's plastic, it's not glass. Modular power supply. AM 888M TAC G ASRock. This looks like an old AMD motherboard. You got 1, 2, 3, 4, 5, 6 hard drive bays here. There's another 1 terabyte Western Digital. These are what hold it in place. This may be interesting. If I don't have any additional parts, I may have to scrounge. 2 memory sticks. Once I get this thing fired up, I'll tell what those are. It's dusty, but not too bad. Okay, yeah, here's another SSD. 2 screws folded in. We'll definitely need tools. This looks like it's a 64 gigabyte drive. Cable management's all back here. We got 1, 2, 3 SATA ports, SATA power cables. Motherboard has 1, 2, 3, 4, 5, 6, 7, 8. Looks like 8 SATA ports. A couple of expansion slots. CD-ROM player. So looks like I'm going to need some parts for this. I'm sure this front panel comes off. Oh yeah. Yeah. Another flange slot, fan slot. So yeah, definitely going to be needing to do some cleanup with this. Not bad. Could have been worse. Definitely need to do a little cleanup on this case, so we'll get back after we. So these have the grommets, we just don't have the screws. So I'm going to need to take these out and see what size screws these are. Okay. And 1 terabyte. Okay. We know where we need to go from here. Definitely got some work ahead of me to get this up to snuff. Oh, case serial numbers here on the bottom, and we have another filter. Cool. Now that we've taken a look at the various parts that we're going to be using, let's talk about what I want to do as we move forward. Let's discuss the procedure I'm going to walk through to validate all these parts that I've collected together before actually assembling them. At this point, all the parts I've collected are used. I've either found them in my leftover equipment or someone's donated them, but their condition is basically unknown at this point in time. One of the first things I want to do is run SMART against all the hard drives. SMART is an acronym for Self-Monitoring Analyst Reporting Technology, and I can check each of my both mechanical and my solid state drives using this. Most drives that have been assembled in the last few years have this built into them already. We just need a program to look at it. I will be using a program called Crystal Disk Info to do this with. It's freeware and it's easily downloadable. Please donate if you do use it. For the power supply itself, I'll be wanting to check the actual output voltages. I'll want to be looking for AC ripple. I want to look at the current draw and temperature also. These are some standard things, so I'm going to be looking at them. This is something most people probably don't have the inclination to do or the training. Since I started out as an electronics technician, I know how to do it, so I'll do it, but I'm not going to bore you with the details. Unless, of course, there's any real interest in hearing what they are, then of course I'll be happy to do a post about it. I will also be checking the system board, the CPU, and the memory. I haven't really pulled the memory or the CPU. If it comes up, I don't want to disturb the thermal paste, but once I boot the system board, I'll be able to see in the BIOS what's exactly installed. I need to put together a list of any additional hardware I'm going to need. Right now, I know I'm going to need at least a couple of SATA data cables, as there's only 3 in the case. 2 to 4, depends if I want to hook the CD-ROM slash DVD drive up again, and if I want to use more than one solid state drive. Also, I'm going to need a Molex to SATA adapter, because I'll need a few more SATA power connectors, and a handful of standard computer screws. Other than that, we're going to see what else we need as we get through this, but yeah, that's some stuff I know I need to pick up now. This is by no means a state-of-the-art server. It's made from old parts. It's
stuff I've gotten for free or I had from previous projects. So just consider this an example of building a server on the cheap and not building a world-class server. Well, technically it could be world-class depending on how it works, but it's still being built on the cheap. For the case, I've identified it by looking at the label on the front, the tag on the bottom. It's a Fractal Design Arc Mini 2, Mini R2 that is, and it has the following features that are relevant to our concerns. It's 210 by 405 by 484 millimeters, so it's a mini to mid-sized tower. Has two 5.25-inch drive bays, six 3.5-inch drive bays, and two 2.5-inch drive mounts. The case came with three fans, one front, one rear, one top. It also has a built-in fan controller on the front top of the case, which is just a couple of speeds for the fan. This is something you can manually adjust while it's running. It has multiple removable dust filters, again, top, front, and bottom. The system board inside the case is an A88M TAC-G by ASRock. It is a micro ATX form factor. It has an FM2 Plus CPU. This means it's got a AMD A series processor in it, more than likely. Again, we'll find out when we turn it on. It's got 4x DDR3 DIMM slots with a maximum of 64 gigabytes. And it has a gigabit Ethernet adapter on the back. In addition, there are 8 SATA 3 ports, and there's an M.2 slot. This is equivalent to one of the PCI slots, so you can use an M.2 drive here as long as you're not using the related slot. Don't have the M.2 drive, but I'll be using SSD for the operating system, I think. This board's around 10 years old, but it should do the trick. It won't be as power efficient as something newer, but it should work. For the storage drives, at this point, I've got 4 Western Digital WD10EZ-EX drives from various years. The earliest one's 2013, and the latest is 2019. All have similar specifications because they're basically the same model number. The good thing about this is being built in different years, they're not likely to fail at the same time. They're all 3.5-inch form factor, 7,200 RPM. Their list is 1 terabyte. In real life, this is only about 910 gigabytes. So in a RAID 5 array with 1 parity drive, that should be 2.73 terabytes. Not the biggest server I could build as far as storage is concerned, but like I say, it's what I have lying around. 4 SSDs in various sizes also, one 64 gigabit, one 120 gigabit, one 256 gigabit, and one 512 gigabit. I still need to decide if I'm going to use more than one of these. Since I'm using Debian, the OS will obviously fit on the 64 gigabit, but I'm wondering about actually creating home folders separate from the storage drive on one of the SSDs. I'll have to think about this one some more before jumping in. I won't be using an SSD cache. This is a technique where we can use a faster, smaller solid state drive to help improve the performance of a larger mechanical drive. The classic example, at least in Debian, is the bcache program, which allows you to cache data to a solid state drive, and then outside of the user purview is what's needed to be transferred to the larger and slower mechanical drives is done. However, this assumes that the drive speed is your main performance bottleneck, which in this case it isn't. So let me explain. In my current location, we'll be direct connecting to a mesh network node. The network is technically from the ISP 1 gigabit. My measured speed at the node where I'll be plugging in is around 300 megabits. So as a speed comparison, a 1 gigabit per second is 125 megabytes per second. And we've got a slight overhead, so about 95% of that. And we were looking at 119 megabyte throughput. There is some read-write performance because we're using RAID 5, or some overhead for using the SSD as a cache. So Because of the hard drive speed versus the actual network speed, the network speed is the bottleneck, so I can't really, in this case, justify using an SSD for a caching drive. Again, we'll be using an SSD for the operating system. That's it for this video. Got to take a few days to put everything together and install an operating system, but we will take up next time after it's all up and running and I've installed Debian 12 and OpenSSH. So see you then.